Welcome back, ladies and gentlemen, dear viewers. I would like to welcome you to our next session right here at Let's Talk Energy Power On, where today we are talking about everything in regards to large scale. Ladies and gentlemen, it is my utmost pleasure to introduce you to the head of Project Engineering Services right here at SMA. Welcome, Kai Ludolf.
Hello, Kimsey. Thanks for being here. I'm also excited and appreciate. Hello, guests, everyone over there. And it's a very exciting session we have to do about now in the next 45 minutes. And I want to keep you and bring you on the next level, but I'm not alone. With me is Professor Waffenschmidt from the University of Applied Science in Cologne. Hello.
Yeah. Hello, Mr. Ludolf. Hello, everybody. So I'm a professor at the University of Applied Science in Cologne, and my research topic is electrical power grids. And I research on everything which relates to how can we transform our power grid to 100% renewable energies.
Professor Waffenschmidt, great that you're here. Great that you took the time away from your students. I guess online at the moment or in person? Online.
Yes.
Okay,
online,
so
yeah.
Thanks for taking the time away from them and for spending the time with us and our audience out there all across the globe. So, ladies and gentlemen, we're going to talk about grid forming in the next 45 minutes, grid forming within energy management. And Kai, I'd like to begin with you. Sort of to introduce the session, what we oftentimes do, we start with the basics. So tell us which SMA solutions exist to digitalize the energy market.
Let's have first a look on the energy market. There are a lot of stakeholders in there when we look on the renewable integration with PV, with storage, wind, and power gas, for example, and also biomass on the other hand side. And everything is connected in a big grid. And everyone is contributing to the grid on the one hand side, but everyone contributes also the energy to the market. That means we have a big grid also in the communication and digitization point of view. And that's very important. And to see it, it's not so easy, it's getting much more complex. And it's our job to reduce the complexity.
So, but how do you manage all that?
So with our IoT platform, NXOS, we are keeping our customers and the plants itself on the next level. So we see nevertheless an increasing share of the digitalized energy generators in Europe when we speak about gigawatts and also in the world. On the other hand side, just especially for the German market, when we look on the feed-in tariff topics, a lot of people have, for 20 years ago, a PV plant on their rooftops. They want to engage their system with batteries. So that means also the battery pricing are falling. It's a very important point. And on the other hand side, the increasing demand on electrical energy. Also when we are looking on the mobility sector, electric cars, vehicles, scooters, bikes, there are a lot of demand over there, rising. And nevertheless, we see that the energy sector itself, when we look in the past with the market, stock market, the day-ahead hedging and so on, and the digitization is getting much more quicker in front of us.
And how does that, I mean, it all sounds great, but how does it look like in real life? And what does the system, or what would the system look like?
Yeah, the system is a platform system, is a hardware and software application. And with this platform NXOS, it's possible for us and for our customers to enable the intelligence of the whole lifetime of a PV plant. Starting in the beginning with planning from a developer and an EPC, for example, with our experience, we are ready to reduce the risks and to maximize the profitability for the customers. And on the other hand side, efficiency for service is rising because we can penetrate remotely through NXOS platform to the PV plant or hybrid plant itself. And at the end, we are managing the complexity for our customers.
We're going to have a quick microphone introduction here so that the entire world and not only Professor Waffenschmidt and I can hear you. Did we hear anything? Should Kai repeat? Yeah, we did. Okay, very good. Okay, so let me come to the next question. Did you bring an example? We'd like to see an example.
Yeah, on this slide, you can see there a small, or let's say a large-scale system. You have the PV modules connected to the PV inverter system, and also additionally there is a battery inverter with a battery container system. And from the communication point of view, they are connecting to the SMA monitoring system, and this is sending the data on all of the parameter settings and very important topics to our Sunny portal. And on the next slide, I want to show you a small point of the Sunny portal. There we have a customer with a PV plant around about 4.2 megawatts. And on this dashboard, you can see the actual status. That means the PV, the power, what, for example, also failures and warnings. You can flip through every kind of inverters and have a look on this. And so this is the first step, and to see how the plant is working. So you don't have to drive over there, have a look on the display of the inverter anymore. You can see it. And also, when you download the app on the iPhone, it's also working.
And you can have it with you at any time.
Yeah.
So I'd like to know what device controls this system.
So the device which we are using in big power plants is the power plant controller. The power plant controller is the hardware development where NXOS is also included, and the power plant manager controls all the energy flows within this system. And what is very important, it creates a single all-encompassing system, so that we are speaking not about inverter, battery inverter, it's a whole system at the end, a solution.
And what are the advantages, the general advantages of energy management? What can you tell us about that?
There are a lot of advantages. Let's have a look on the next slide. As I mentioned, all the data is collected together in the Sunny portal. So within the Sunny portal, it's also possible to have an analysis. That means, okay, lifetime of the inverter, also the degradation of the modules, voltage and current and all these things. And nevertheless, you have an easy monitoring system, as I mentioned and showed you there on the slide, for example. And also the interconnection, not only with Sunny portal, also with outer SCADA system is possible. And what we are doing in the last years, or let's say 5 to 10 years ago, we implemented PV in diesel grids. When we speak later a little bit about island grids, so that means the electricity will be enabled by diesel gensets, and to reduce the cost also for diesel, we are penetrating with PV and also with batteries in there. Another more advantage, for example, as Michael and Bernhard spoke about the service topic. So we have easily access to the PV plant or hybrid plant nevertheless, and at the end you can be very good in seeing the costs, and much more important is the security. So this is an overall topic now. It's only 4 advantages I showed. There are much more.
But there's, of course, many, many more.
Yeah.
Okay, so and how many use cases are there? Or
So
you
at
still
the
have-
end,
yeah.
you can see the picture from the beginning, that the power plant manager in the middle, yeah, it's working together with different kind of applications. It's like a spider in the net connecting all the strings together. And there are a lot of use cases, for example, we have done in projects. So the power plant manager is operating plants nevertheless. Also, it's managing PV power. In some areas in the world, we have to curtail the PV energy because the demand is not so big, yeah, so we have to reduce it. On the other hand side, there are a lot of projects in the UK. 3 years ago, we have connected batteries to the grid itself. So that means it's management of batteries directly for primary frequency control, for example, and also that Bordas Holm is one topic working on. Enabling grid services. So we are supporting together through the power plant manager with the parameterization very interesting and very important grid services. When we speak about Australia, for example, there's a wide and very weak grid, and the PV plants have to work there in different kind of various regions and various topics. So we are facing here also the edge of technology sometimes. And as an example, microgrids, island grids, like Bordas Holm, for example.
And are these small grids or an island?
Kimsey, there are both. There is a lot of them. So in the last years, we had small islands, big islands, when we speak about geographically. But when we speak about island grids, we are speaking about encapsulated grids. So with no interconnection, like we in Germany, we have this connected in Europe. But what is important when we are looking on these island grids, you need much more functionalities. And also this functionality I want to explain and later in a movie that was implemented in Bordas Holm. So important is, for example, the black start feasibility. If you have an island grid fired by diesel generators, sometimes the machines are not working, breakdowns, and then there must be a recovery from the black. So you need to restart again so that every system can work easily, nevertheless. And also when we speak about islands itself, I think our viewers have seen the movie from Center Stations, for example. There we implemented PV and a battery together in these diesel grids. And so then we have much more stability in these areas. And when we speak about utility grids, so have a look on the bigger size, not only on the island size, there's a growing of complexity of power and transmission. I think we can speak about a little bit later about this, because Bordesholm is a very pioneer project for this and very exciting about this. And as you see on the slide, only a few of plants of them are still doing these kind of jobs. To see the fully integrated area restart from a coordination. We had these problems 3 years ago in Australia. For example, there was a big blackout through the wind industry. And so they learned and they raised up the certification of the inverters and, let's say, the grid integration features which are needed. And we see also, not in Bordesholm, but worldwide, that grid forming and black start feasibilities are very important to raise up the renewable integration.
You brought us a video to Blackstart also, I believe?
Yes, one colleague from mine, he's also still working together with Professor Waffenschmidt during the tests in Bordesholm. And let's have a look on the movie.
Hi everyone. Welcome to our hybrid system lab at SMAs. My name is Paul Robert Stankart. I'm responsible system engineer for hybrid system technology. And today I would like to show you how the Power Plant Manager as a product can be used in hybrid systems to perform the functionality of black start and synchronization. So the special system functionalities of such a hybrid system would be black start functionality and the synchronization functionality. So imagine if there's a power outage of the overlaid grid, it would be possible to completely isolate the small town from the overlaid grid and power it up with the black start functionality, run it for a couple of hours depending on the battery size and the renewable integration, and synchronize it back to the overlaid grid. So in case of a failure of an overlaid grid, it usually takes a lot of time to restore the whole system. So you would have to wait for the overlaid grid to come back. In our case, you can actually start with a black start right away. So it just takes a couple of seconds to start up the system. And that's pretty much what we'd like to show you today. What we just simulated is the black start functionality and the synchronization process, which is also coordinated by the Power Plant Manager, which is right here beside me. So basically what it does is it coordinates all the transitions within a hybrid system. Coordinates the starting of inverters, the synchronization between inverters, the load sharing, but it also synchronizes the whole island system to the overlaid grid. This is basically, it's a process that you can estimate to be fairly complicated because it's two power grids that have to be synchronized onto each other. So there's two different voltage sources, there's two different frequencies, and you would have to synchronize those two grids onto each other, which takes a couple of seconds. And afterwards, when it's synchronized, you can close the switch and the system is grid tied again.
Thank you very much, Kai, for bringing this video about Black Start. And before we move on to our guest, Professor Waffenschmidt, I would like to let you know, ladies and gentlemen, that if you have any questions, you can ask Professor Waffenschmidt or, of course, also Kai Ludolf a little bit later on in the show in our Q&A segment. So now, Professor Waffenschmidt, we heard about Black Start. We've sort of got mentioned Bordesholm and what an amazing project this is. You, Professor Waffenschmidt, you were right there when it got started last winter, and you were there also for the last summer, and you were also there for the big test last winter. So tell us all about it.
Well, the exciting thing is that this battery in Bordesholm can be the blueprint for our future grid, for our future power grid. And the thing is that our future power grid has to correspond to the distributed nature of renewable energies. And that's a little bit contrary of what politicians think, and because lots of them think of Germany as distributed in two parts. The northern part where we can harness only wind power, and the south only sun power. But that's not true, as most of us know, because we can get renewable energies everywhere. And that means that the power grid also needs to be organized in a distributed way. And for this kind of cellular power grids, we need parts that can organize this one. And this battery in Bordesholm is a pretty good example to do something like this. Bordesholm is located in the north of Germany. It's not an island, it's a little village close to Kiel. And the Versorgungsbetrieb Bordesholm, the VBB, they took money to build such a battery which can manage the power grid. Lots of partners contributed to it. You see a few of them on this panel, including SMA. And Bordesholm has about 7,500 inhabitants. They consume a maximum of about 4 megawatt. The installed photovoltaic power was at that time when we made the experiment about 1.4 megawatt distributed on different roofs. And they have a biogas generator of 2.4 megawatt. And meanwhile, they have additional PV power such that in good times they can generate as much power as they need with renewable energies.
And what was the basis to realize this huge project? I mean, it's gigantic.
Well, the thing is that the Versorgungsbetriebe Bordesholm realized that we have to do something for the future. So they invested the money to buy a battery of about 15 megawatt hours, and it has a maximum power of 12.5 megawatt, consisting of 7 independent battery strings. If you look at that picture, you can see
Thumbs
7
up.
doors in the building, which correspond to the 7 strings of the battery.
Okay.
And they earn the money back with a normal operation with primary control market. And they got some additional funding from the government to imply very special functionality to operate the battery in case of emergency as islanding power grid. As a grid former. I will come to that a little bit later if you like.
Absolutely. So what more can you tell us about the battery, this magical battery, it seems?
Well, as I mentioned, they earn the money with primary control operation. That means they go to the stock market, offer their battery, and they have a pre-qualified primary control power of 10 megawatt, which is quite a lot for a battery. It's in operation since 2019. Something technically, the batteries operate in current control mode if the battery is in this primary control operation. This is because of the relating standards. It has to operate in this particular mode. For the islanding experiment, the battery can switch into a different mode, which is the so-called voltage and frequency droop mode. And in this case, the battery is able to switch seamlessly from grid operation to islanding operation. And in this case, if the battery operates as in islanding operation, the battery manages the whole balancing of the grid. So starting from a very low time scale, such that it can deliver lack of renewable energy or can charge the battery with excess renewable energy. And it goes into millisecond range where it keeps the voltage and even the grid frequency totally stable. And the most important thing is, which makes this battery so unique, is that it can switch from one to the other operation seamlessly. The customer don't see it. And we had an experiment, where you can see here myself with a hat on the right side. You can see Mr. Frank Günther, who is the general manager of VBB, and furthermore, Silvan Rumeni, my research assistant. And you can see here...
More thumbs up.
yeah, you can see here that particular point of time when we switched off Bordesholm from the main grid. because we really did it.
So, but then did people notice, or what happened?
No, and that's the nice thing. They didn't notice anything. Well, VVB prepared a lot for this experiment. Yeah? So they set up a whole control center. Yeah? They invited press representatives, yeah? And they showed the whole process on a video screen. Yeah? It was like started a moon rocket. Like
Except you see that you don't see anything. I mean,
yes, and they also prepared how to say a hotline, a telephone hotline, yeah, because they expected at least one person would call because they knew something special on.
my coffee machine isn't working, or
like that. Yeah. But definitely nobody called. Yeah, and we could show the measurements online on the video screen in that particular center, and we measured the grid voltage with 128 measurement points per period. Yeah, and we showed the sinusoidal slope on the screen online. And when we definitely switched, you didn't see anything in the voltage slope. Yeah? Actually, when we tested these experiments before, not with Bordas Holm, but with an artificial load, and when we did it the first time, we really had difficulties to find the point of measurement where we switched, because there was definitely no change in the voltage slope.
And of course, it was also the SMA engineers that helped make this such a great success, right?
Yeah, you can be very proud of your engineers, because I was really astonished how they did their work. You can see here a picture. These are measurements of the voltage slopes during the islanding experiment. You can see the gray ranges of time where we connected Bordas Holm to the mains grid. And during the white background times, the city of Bordas Holm was connected to the battery. And you can see here that the battery is even better able to keep the voltage constant, as it is the case when it is connected to the mains grid.
Wow. And if you would have to summarize, like, what did this experiment prove?
Well, to my opinion, it proves that we do not need large power plants to keep the grid stable. We can do that. We can do primary control with batteries, with other renewable energy sources, and we are even able to keep the voltage and the frequency of the grid stable. So if we if we multiply these kind of batteries, yeah, we can also operate our grid without large power plants in the future, in the near future. Yeah. Technically, it's possible.
Kai, I read that you're also nominated for a prize in regards to this project. Can you tell us a little bit about that?
Yes, we are nominated not only for the project, also for the Power Plant Manager, for the eSmarter Award. We'll see this in the next days. If we win these projects, or let's say these prizes.
Fingers crossed.
Fingers crossed. And it's, when you're looking into the past, these kind of pioneer projects, we have done a lot of them. Sanctostatis, for example, together with our company SMA. So Sunbelt, for example, they are doing these kind of projects also on the worldwide. And this shows us, and Professor Waschmidt said also about the young engineers. You saw Paul over there. He was a student in the beginning times, now 10 years ago. Now he's a very mature engineer. And hopefully you can see that all these projects, and we speak about these pioneer projects, needs very competent colleagues over there. And it's a wide area you need. And it's very interesting. And I'm proud to be with these teams and together with my colleagues to work on these kind of projects.
Absolutely, absolutely, and you should be. Professor Waffenschön, thank you so much for your presentation. Now, we saw the slides, we heard you talk, but you also brought us a film, because I think that really, you know, images, of course, speak a lot more. So if it's okay with you, we're going to have a look at the Bordesholm film right now. Here it is.
The name Bordesholm means at the shore of the island. With a unique project, the municipal is living up to its name and is quite literally heading towards new shores. The public utility company Versorgungsbetriebe Bordesholm, VBB, and TH Köln, University of Applied Sciences in Germany, simulated a large-scale power outage. They disconnected Bordesholm from the European utility grid for 1 hour via the synchronous tie switch. Best of all, the 8,000 residents of Bordesholm did not even notice it. All households, businesses, and institutions were still supplied with electricity without any interruptions. It no longer came from the European utility grid, but within the Bordesholm standalone grid, 100% from renewable energies. From this moment, Bordesholm is disconnected from the European utility grid, and the SMA energy system large-scale takes over the electricity supply. With the SMA system, the Bordesholm utility company supports the European utility grid with frequency containment reserve during normal operation. Thus, they contribute to a stable utility frequency of exactly 50 Hz, a lucrative business model for the utility company VBB. However, the SMA energy system large-scale can do so much more. This is exactly what the experiment proves. Normally, the European utility grid supplies all consumers with electricity. Renewable energy sources also provide electricity and feed into the utility grid. The utility company VBB can disconnect the municipal's grid via the synchronous tie breaker. Within fractions of a second, the SMA energy system large-scale establishes a standalone grid, and the renewable energy sources take over the electricity supply without lights flickering and without disturbing sensitive operating equipment. Once the upstream utility grid is available again, the SMA system automatically synchronizes the standalone grid with the utility grid and reconnects to it. A stable system, and only with renewable energies.
Today, we successfully demonstrated that it is possible to operate reliably without nuclear power plants or those fired by fossil fuels. If this were done on a larger scale, it would be possible to supply the world with electricity far more efficiently and exclusively from renewable energies with the aid of battery storage systems, and even finally to tear down coal-fired and nuclear power plants. After all, they would no longer be needed. With the pilot project, we are able to show that it is possible to operate a complete utility grid with renewable energies and a battery to support the grid. That would practically be the blueprint for supply derived entirely from renewable energies.
The Bordesholm standalone grid is proof that entire regions can provide for themselves using 100% renewable energies. Bordesholm is now a flagship for Germany, Europe, and the whole world.
What a truly amazing pilot project we just saw here with Bordesholm. Before we get to the Q&A, just a quick reminder, if you have any questions regarding Bordesholm or grid forming, you can pose this question right here in our interactive area, and then we'll be good to go and pose the question to Professor Waffenschmidt and also Kai Ludolf. So Professor Waffenschmidt, I would like to know, when is this going to happen in my hometown? When are we going to be able to be shut off the grid?
Well, the thing is that at the moment we have not the possibility to immediately switch the battery into islanding grid operation. I explained that during normal operation the converter operates in current control mode. In this mode it cannot operate in islanding operation. So what we would need to have is a daily operation in voltage control mode, which would be possible but is not allowed because of standardization. So that means if we have a sudden blackout now, even Bordesholm would feel this blackout first, but we would be able to black start the battery in-islanding operation, such that within a very short time of a few minutes, well, it depends on how fast an expert would be available, yeah, could switch the battery on again, and Bordas Holm could have power while others not have. Yeah? And we are planning a successor project to investigate those kind of things. The other thing is that we did the test for about an hour. Yeah? What we did not investigate is to operate an islanding during a longer period of time. That would require measures that we could be able to switch off loads if we don't have enough power, or to switch off generation if we have too much and the battery is full. So this is something which we are going to investigate. And if you're talking about your own home, yeah, this is also something which we want to investigate in this successor project. What is really definitely necessary? What are the basic requirements to make this possible in other kind of power grids? Because every power grid is a little bit different from each other. They have other requirements, they have other resources, and what are the basic requirements that we can make it? This will be investigated in a future project.
And hopefully answers will be found very, very shortly also.
Yes, yes.
That might take a minute. Okay. So if you gentlemen are ready, let's get to the questions that were posed by you, dear ladies and gentlemen, dear viewers, to Let's Talk Energy. How does SMA mitigate the risks and maximize the profitability for our customers like EPCs, IPPs, or investors?
Yeah, so with our experience within the last 10 or 20 years, we support our customers in the various regions during these value stream in a project. So starting with developers looking for land, for example, grid connections, and then there's some financial topics and hand over to EPCs. And we learned that with our experience of design and nevertheless, let's say the DC-AC ratio, how much modules to the inverter sizes are changing, grid integration features, as I mentioned, also together with Professor Waffenschmidt when we speak about these kind of questions. And so we can reduce the risks for these kind of customers that at the end the service is very good and also during the operation everything is smoothly. That is very important. And so we can reduce the risks for our customers because we have the knowledge and we can support them as SMA engineering services and to work together with these kind of customers to reduce the risks. We have done this in the last 3 to 4 years, also in Australia, one of the biggest utility markets for us. And with our expertise and together with the Power Plant Manager and all the parameterization of these kind of grids with very short circuit ratio, it's very important for us, and that's why the customers are calling us every day. Australia in the morning, USA in the night.
No rest for you. Do you have experience with grid forming only in Germany at projects like Bordesholm or also internationally?
So there are also internationally projects. We see the trailer about St. Eustatius 2 or 3 years ago. But when we speak about, for example, about household applications, we have the product Sunny Island itself since 15 years to connect it to batteries at your home, and then you are safe if someone is switching off. So there are a lot of projects worldwide also to implement PV and battery in diesel grids, so grid following. So 2 years ago, there was not black start feasibility and grid forming itself, but there was a grid following, so we can switch off the diesel gens. Then the grid in St. Eustatius was fired by the battery energy power. Yeah, at the end, the sun goes down, the battery is getting low, then they're starting up, firing up the diesel genset. So there are a lot of projects worldwide, but these, like Bordas Holm, is unique.
Absolutely, a unique project. Our viewers would like to know next, how can the PPM be customized?
So the PPM is an application, a hardware application, and it can be customized due to the different kind of certifications and requirements from customers in various projects. So it's not an open source software, let's say, but we had a lot of engineers still working on these topics. So that we have projects, for example, in the US and Australia with special requirements. Then we can change the code together with the software department in my department, making tests, validation, acceptance test, and then it's fitted for the customer.
Let's get to the next question. I do have to apologize. Most of these questions are going to be entirely SMA related and not really for you, but I'll try to get you back in action as soon as I can. Let's see what the next question is. Are there any regional restrictions to the use of power control of SMA?
Not really, but it's depending on the certification of the power plant manager itself. When we speak about Europe, Australia, for example, and other regions, we are in the IEC world. In the US, it's the UL world, it's a different kind of certification. And the market in the US and the customers in the US are a little bit different driven. They don't need directly the power plant manager. Someone has an own, let's say, hardware software solution. But nevertheless, you can use it everywhere. And NXOS, nevertheless, it's one part of the power plant manager. It's also used for household applications, or let's say customizing applications. Also, we have a PV plant in my family. It's about 700 kilowatt peak. It's a free field application. And also we have an NXOS data manager inside, which is connected to the spot market where we are selling the energy.
Well, you're sitting at the source, so of course you have to have a PV
I think this was my experience over the years. It's not only the source, but also this PV plant was something like a test center, a field test.
Oh,
That
even
means
better.
also, yeah, of course. Also, these systems must be tested at some customers, and we did it.
And you put up your hand and said, here.
Yes, I put up my hands. What is good? What is bad? What we have to change?
Yeah.
And also through the years, there are different kind of data technologies, IPP technology, for example, and so on.
Dear all, here's the next question. Thanks for the interesting presentation of Bordas Holm. For how many hours can the battery withstand the outages situation, for example, in case of disaster? Where is it not possible to restore the grid within short time? Thanks in advance. Great question.
Well, I'm not exactly sure about the meaning of the question.
Okay.
Therefore, I give two answers.
Okay.
Well, the first answer is if we have a sudden blackout, the battery has emergency power supply, which can supply the controller for about an hour or two or so. So that means we have enough time to restart the whole system, and we have also power for that. So if we have restarted the system, whole Europe may be black, only Bordas Holm may have the power. And then it depends on the generation of renewable energies in this particular area. So you should not consider the battery as the main energy source, but as the balancer to manage the energy flow. And how long you can supply Bordas Holm depends on how much power is available in this particular area and how much power is needed. Yeah. As I mentioned in our future research project, we are want to implement and research on measures how to prolong this time such that we can be able to switch off loads which are maybe not so necessary. Yeah, so we can extend this time, and meanwhile, in addition, additional PV plants are installed in Bordesholm, which also extend the time. Yeah? In principle, it can be infinite.
Fantastic. That's the best answer, no? Let's see what the next question is. Where are the key markets SMA's experience in power I don't fully understand the question grammatically. Where is the key markets SMA experience in power control originates from? Where are the key, in regards to power control, where are your markets worldwide, I guess is the question.
I think this is worldwide. For me, coming from the large scale unit, we are looking mostly on Australia, Asia Pacific regions, and also the United States, US market, and also South America. Europe is a little bit changing there. The market by now is much more residential and commercial, but also there is data management and energy management very important. And the power management, when we speak about energy management, it's on the less speed, let's say. But if you need power management, for example, to switch off from island to normal mode or normal operation, then you need speed and also speed system. And this is included in the Power Plant Manager. So we have combined both, the best of both worlds inside. And that's what I mentioned also, Australia, weak grids. We have to handle a lot of grid integration features and topics at the same time. And that's why we need speed. So big markets for utility markets. And we see that now upcoming markets also need grid forming and batteries. When we speak, the battery prices are going down. The business cases are changing. We're speaking about sustainability, very important topic. So also for the batteries and all the grids itself. So it's worthwhile. We can do it on the commercial side and also on the utility side.
Absolutely. Did you want to add to sustainability, perhaps?
I would like to add to the keyword speed. Yeah, if you talk speed of the control system, I was really amazed when we did some preliminary experiments where the battery had to deliver its full power within one period of the power grid. So we did a similar experiment as in Bordesholm, but in Bordesholm we prepared the battery for it. In a preliminary experiment we did not. So the battery had to deliver 4 megawatts instantly. Yeah? And even in that particular case we had no drop of the voltage at all. We had some oscillations, but these were minor. You still could follow the sinusoidal curve, and that showed impressively to me, how the control speed, the technical speed of these controllers is able to keep the grid stable.
Okay. Okay, we have another 3 minutes. Let's look at the next question. Being the central controller in a microgrid, does the power plant manager have redundancy? Is the question?
Yes, the system has a redundancy, mostly and still working when we have necessary projects with the necessary security. We have a backup system, let's say, inside. So if there's a breakdown or some kind of freeze or something like this happens, also to the power plant manager, there will be a backup.
Okay.
Very important for security.
Of course, yep. Can the system go from the islanded mode back to the grid connected without interruption seamlessly as well?
Yes. For this experiment, we installed a so-called synchronous switch, which only connects the two grids when frequency, voltage, and phase match. But it showed that it was not really necessary because the battery controller already matches frequency, voltage, and the phase with the main grid, such that even a normal switch would be sufficient.
Oh, okay. Is SMA offering solutions for large-scale data centers, Google, Microsoft, Equinix, since they become even larger energy consumers than significant cities?
I don't want to reduce it on data centers. I think there is a lot of applications worldwide. Data centers on the one hand side need security, warehouses, for example. We have a spin-off, the Coneva is also looking for to integrate the sector coupling we spoke about together also in these kind of regions. And yes, there are solutions. Yeah. For example, Bordas Holm or other grid forming with battery and PV is able to have the, let's say, stable supply of energy. You saw the voltage. Normally the grid is changing with the frequency and everything like this, or let's say the voltage value. But then with the grid forming, it's self-stable. It's very important for computer systems. So if there's a blackout, small blackouts, in Germany we have in the year 200, 300 dip downs in the voltage. If it's more than 100 milliseconds, some computers will die. Yeah. So there are solutions for every kind of application, if it's small, middle, or large.
We have time for one final question, and that's a question to you, dear Professor. Why was SMA selected for this pilot project? Did you consider other manufacturers? And you have to answer within 30 seconds.
Well, it was not my responsibility. It was VBB who selected. So it was a formal, wie sagt man, Ausschreibung.
I don't know.
The opposite of an offer.
Like a competition?
Competition is a good word. Yeah, and
Sorry, this is
the battery, the system manufacturer, RES, selected all the components, and fortunately, they selected SMA.
Great, fantastic. Thank you so much, gentlemen, for your presentation, for the fantastic pilot project, for answering all our questions. I hope you have a safe journey back home and your students didn't miss you too much. And we, ladies and gentlemen, will take a very short break, 15 minutes, and then we are coming back to you with our last session of the day on sustainability right here at Let's Talk Energy, Power on Large Scale. See you soon.